Hello, my name is Paul Summers, and I'm a fifth-year PhD candidate in geophysics at Stanford University. I work with Jenny Tsukaly investigating the processes controlling the evolution of Antarctic glaciers with a specific focus on the shear margins of Thwaites Glacier. Antarctica today is a major driver of sea level rise and, more importantly, uncertainty in sea level rise. We can see from the IPCC Special Report on Ocean and Cryosphere, where they highlight the overall projected sea level rise from Antarctica in the middle left plot here, where we see both the contribution to sea level rise for the red and blue, a high and low emissions pathway, as well as the overall uncertainty or spread for both of these projections shown as the light red or the light blue. And we can see here that panel F, the Antarctic ice sheet mass loss, is a major driver of overall sea level rise, but most importantly is a very large driver of uncertainty due to the uncertainties in modeling the future of the ice sheets of Antarctica. Regionally, when we zoom in on the continent of just Antarctica, we see that the most rapid mass loss today is coming from West Antarctica, focused in regions of Pine Island and Thwaites Glacier, where we focus our study today. A majority of mass loss from Antarctica today leaves the continent not as liquid water flowing off the surface of the ice, but rather as whole frozen ice breaking off and calving as icebergs at the coast. This ice flows to the coast from further inland through narrow tributaries termed shear margin or ice streams. We can see those ice streams on this plot on the right here, where we see the overall surface velocity of ice across the entire continent. The dark blues are slow, stagnant ice, termed ice ridges, and interspersed between those are these regions of fast flow, which are the warmer colors, orange and red, flowing up to kilometers per year. And this is how the ice is transported from inland where it falls as snow to the coast where it breaks off as icebergs. The overall width and speed of these ice streams, defining the overall flux of ice flow through these tributaries, is primarily controlled by the shear margins, the lateral boundaries, where this fast-flowing ice very quickly abuts solid, slower ice ridges. My research focuses on modeling the future evolution of the shear margins at Thwaites Glacier in response to the currently ongoing rapid thinning of the ice surface. Our model that we developed solves for both the ice velocity within our domain as well as the location of the shear margins where rapid sliding transitions into stable frozen ice within the ice ridge. Our results indicate that there's potential for outward shear margin migration, particularly in inland Thwaites Glacier, potentially leading to accelerating ice loss in the coming decades. I'm excited to meet with you all soon, and hopefully you'll stop by my poster where we can talk more about my research. Thank you.